Okay, in this video we're going to take a look at kinetic energy. So another type of energy here. Kinetic energy is essentially the energy that moving objects have. So let's have a little bit of a look here. So kinetic energy, again I've put up my triangle. Now we'll come to the triangle in a minute, but kinetic energy is often the formula you'll be given as energy, EK. So energy, and the type of energy here, the K is for kinetic, equals, and it's half mv squared. So let's have a little bit of a talk about this in terms of what does this formula represent? What are these values here? So we've got here, the m probably looks familiar. So this is the mass. And it's saying that a moving object will have more energy if it has a greater mass. So you can see if I make this number here bigger, I'll get a bigger answer over here. And in fact, it's a direct relationship. If I doubled this number here, I get twice as much energy over here. So what we're saying is basically, if you get hit by a car, that's going to have a lot of energy. But if you get hit by a truck, that's twice the mass. It's going to hit you with twice as much energy. Now the V over here should look familiar too. So V is velocity. Alright, so V is our velocity or speed. But it's got a little squared here. So it means the relationship, and we'll look at that in a second, isn't quite 1 for 1. So if I double the speed over here, it's going to increase my energy, but it's not going to be a double kind of or a straight 1 for 1 relationship there. So doubling the mass here would double the amount of energy, but doubling the speed actually has a slightly different effect. But we can still say the amount of energy an object has is proportionate to your mass and velocity. So an object that's moving that has more mass, if you get hit by a truck instead of a car, it's got more mass, it's going to have more energy when it hits you. A car that's going faster is going to have more energy when it hits you. So before we will have a look at that in a little bit more detail, how that relationship between those two values, how those two values affect the amount of energy. But first we're going to have a look at rearranging this formula because it is a little bit more tricky. It's a little bit more tricky to rearrange this. Sorry, just fixing up my V there. Alright, so to rearrange the formula, again, we can use a triangle. So we can put EK up the top here. And so if you get given this formula in the exam, you could always make your own little triangle like this. So just remembering EK here would go at the top. And essentially what we can do is we can then use that triangle to, rearrange it to get our other values. So if we wanted the mass, if I wanted m, what would my formula be? So if I want m here, the mass, it would be the kinetic energy, EK, divided by half times, so I'll just put half there, V squared. So we'd take the V squared and halve it, alright, and then the energy divided by that. So it looks a little bit more complicated, but again, it's just rearranging those different things here. Now the last one, if we want to work out velocity, if we want to work out what the velocity is, it's a little bit more complicated, because if you look here, if we take the V squared here, okay, so I take V squared is going to be equal to, it's going to be equal to EK divided by half of m. Oh, putting the m there, that's silly. Half of m. Okay, now we've still got this little squared thing, the pesky squared thing here. So what we can say is, to get rid of the squared, we've got to square root both sides. So if I square root that, the opposite of squaring is doing the square root. So I square root this side, and that just gives me v. And on the other side, we end up with the square root of and our entire formula so far goes underneath that square root, the EK divided by half of m. So if you're doing this, work out what half of m is, take the kinetic energy and divide by that, and now the thing you've got to realize is you've got to take your entire answer here and do the square root. So you can't just plug into your calculator the square root and then EK divided by blah blah blah, because you'll actually only be doing the square root of the energy at the top here. Okay, so you've got to take the square root of the whole thing, so work out the answer of, you know, what this is here, the EK divided by half m, and then take the square root of that. So a little bit complicated there, and we'll look at in one of our later questions how we can actually, in the next video, we'll do a problem that actually involves, you know, doing this. But hopefully you can see how you can rearrange this equation here. So m, if we want m, m here in the middle is going to be equal to EK divided by half times v squared. Kinetic energy is just half times m times v squared, and our v squared is equal to EK over half times m, and then we've got to square root that answer to get v rather than v squared. Okay, alright, let's have a look. I think I've got a couple of little problems here. Alright, let's have a look. Yes, so I've got a nice fast car here. It weighs 1,500 kg, and we're going to say it's travelling at 100 meters per second. Now, I think when I was doing this I was thinking kilometers per hour, because that's a ridiculously fast speed, but it doesn't matter, it didn't occur to me at the time. But so although this is a ridiculously fast speed, it doesn't matter. We'll just use that for our calculation now anyway. Alright, so 1,500 kgs, 100 meters per second, what would the kinetic energy be? So this is going to be a really big value, given my speed is ridiculously large, but anyway, we're going to say kinetic energy here would be equal to half mv squared. Okay, so kinetic energy is half mv squared, so it's going to be a half of 1,500 times 100 squared. So half of 1,500 times 100 squared. So let's do that. I'm just doing that in my calculator. Alright, and we'll get a value here which is 7,500,000 joules. Now, like I said, that's a ridiculously large number, and one thing we can do to make it a little bit more manageable, or a little bit smaller, is we could actually say this is 7,500, and we could say kilojoules. So whenever we use a little k, so it should actually be a lowercase k, that's saying 1,000. So you can see here 7,500,000. It's actually the same as 7,500,000. The 1,000, the extra 3 zeros there. So whenever you see a k like this, it's telling you there's an extra 30 on the end. And you can think about that. You know, someone might walk up to you and, you know, you might be talking about someone in their job, and they might say, you know, I earn 50k. What they're saying is they earn 50,000, you know, dollars. So the k here literally just means thousands. Alright, so let's have a look at the next one. What happens if we double the speed? So if we double the speed over here, now I've got 200 meters per second, what's going to happen to this, alright, to this now? So we go half, EK, kinetic energy, equals, K didn't register there, half mv squared. So that is going to be a half times 1,500 times 200 squared. And if we plug that into a calculator, alright, we have Alright, this actually gives us 30 million joules. Or we could simplify that down a little bit to 30,000 kilojoules. Alright, so if we compare that to the last one, which was 7.5, we've actually got 4 times the energy. We've got 4 times as much energy. So if we double the speed, we get 4 times as much energy. And I'll just clear that. I want you to think about that for a second. It all comes back to this formula. So the kinetic energy equals, and it was half m, and we're kind of not so interested in that bit at the moment, times v squared. So we're looking at this v squared bit and looking at how it affects the energy here. So if I double the velocity, I actually get 4 times the energy here. And let's think about it. That makes sense. If I had a 2 here, 2 squared gives me 4. So doubling the velocity gives me 4 times the energy. What would happen if I tripled the velocity, if I was going 3 times as fast, going 300 meters per second? Well, it's just like if I had a 3 here, 3 squared, 3 times 3 is actually 9. It would give me 9 times the energy. What would happen if we were going 4 times as fast? So if we go 4 times as fast, well, imagine there's a 4 here next to our little square. The velocity is 4 times as big. Well, 4 squared gives us 16 times the amount of energy. 4 times 4 is 16. So doubling the speed gives you quadruple the energy. Tripling the speed actually gives you 9 times the energy. And quadrupling the speed, 4 times the speed, gives us 16 times the amount of energy. Right, so you can see it's what we call a squared relationship. So whatever we do to the value here, because it's squared, we get that effect on the energy over here. So doubling the speed, quadrupling the energy. And that's why, you're driving campaigns against, you get all these ads on TV that says speeding kills and things, because if a truck or a car, yes, they've got a different amount of mass, and if it's twice as heavy, it'll have twice the energy. But a small increase in speed actually has quite a massive effect on the energy because of the squared, So if you're doubling the speed, you're not actually just doubling the energy, you've got 4 times as much energy. And that energy you've got, that kinetic energy, is going to have to go somewhere if you try to stop suddenly. So if the more energy you have in moving, the more it's going to take to try and slow you down or stop you, the longer it's going to take. And if you do collide or crash into something, the more energy you're going to have when you hit it, so the more damage you're going to do. Okay, so let's have a look. I've got one more little example, and my apologies, it only occurred to me now. I was probably thinking kilometers per hour. Those speeds are ridiculously big. So let's have a look here. We're going to work it the other way around now. So we've now got here a value for energy and a value for the mass. And so what we want to work out here, you can imagine the question might say a car that's 1,500 kilograms has kinetic energy, its kinetic energy is 76,800. What is its velocity? What is its v? So how fast is it going? So I would write these down. I'd put, my E equals this, M equals this, V equals question mark. That's what we want to work out. So we're going to have to rearrange our formula. So let's start with, the standard formula was EK equals half mv squared. Alright, and we can put that into our triangle if for some people that's helpful. So we'd have energy at the top here, and we've got half m and v squared down the bottom. And so to work out the velocity, well, we start with, we'll take v squared for now, equals, okay, so v squared equals our energy divided by half of m. So in this case, we could already plug our numbers into that and work it out. So if I take, alright, in this case, you know, it would be 76,800 divided by half of this, which would be 750 kg. Alright, we could work that out, but we'll go straight to, so V, to get V rather than V squared, we've got to square root both sides. So we can square root this, but if we do that, we've got to do the other side. So it'll be the square root of the E over half M, which equals, that's actually the square root of, so we've got 76,800. Now actually, you've got to be careful here, 76,800, oh, it's kilojoules. We've got kilojoules here. So it's actually 76,800, it's 1,000, we've got to add the 1,000 on the end there. Right, it's actually 76,800 million. Right, 76,800,000. Sorry. So the the K here, tells me I've got to add another 3 zeros on the end there. Right, so a little trick or a little trap to watch out for there. And that's going to be divided by half of M, half the mass. So half times 1,500 is actually 750. Alright, 750. So this equals, we're going to have at the very end the square root of. So let me take my 768 number, 76,800,000, plugging that into a calculator, divided by 750. Let me just get rid of that notification. Alright, so the answer here is, we get a 102,400, and if we take the square root of that, square root of, where is it on my calculator, there we go, and this will actually equal, over here, sorry, grab the pen again, this is actually equal to the square root of that, and the answer, the final answer is 320 meters per second. Now if that was kilometers per hour, which is what I was thinking, wasn't thinking too much when I came up with the question, 320 kilometers per hour is getting up there amongst some of the fastest cars in the world. 320 meters per second, we're getting sort of much faster than the speed of sound, and I'm trying to remember off the top of my head what the speed of light is, but we're getting ridiculously fast there, so it's a little bit silly. A car wouldn't actually be able to go this fast, 320 meters per second, but it doesn't matter. At least, you know, it was just an example to show how to do the calculation. So here, if we want to work out the velocity, you've got to first rearrange the equation, and it's probably best if you're going to really need a calculator here to do your square root. And it's the square root, work out the value underneath first, take the square root of that, and there's your answer. And speed, velocity, our standard unit there, meters per second. So if you got a little bit confused there or stuck, flick back, have another watch, but otherwise we're going to move on to an example that actually involves both kinetic energy and gravitational potential energy.